The topic of this video is graphing inequalities, and specifically we're referring to linear inequalities in the Cartesian plane. Let's look at a problem. Graph the following inequality. 3x minus 5y is greater than negative 15. Okay, so we're going to go through the 3 steps for this kind of problem. Step 1, solve your inequality for y if it has one. If not, solve it for x. Step 2, pretend that it says equals and graph your line. Step 3, shade one side of the line depending on the sign of the inequality symbol that you have and the variable that you solved for. Okay, let's go ahead and go through these 3 steps together. So the first thing we're going to do here is we're going to attempt to solve this for y, and I'm going to subtract 3x on both sides of my inequality. So on the left, the 3x and the minus 3x cancels, leaving me just with the negative 5y is greater than, and then I have negative 3x subtract 15. All right, the next thing I'm going to do is to divide both sides by negative 5. And I'm going to remember 2 things. First of all, when you divide an inequality by a negative, it swaps the direction of the sign. And second, when you take a multi-term expression and divide it by a negative, all of the terms change signs. So instead of negative, negative, we're now going to have positive, positive. So the 3 divided by the 5 makes a positive 3/5 x, and the 15 divided by the 5 makes a positive 3. On the left, we're just going to have y. So we have our inequality solved for y. Y is less than 3/5 x plus 3. Okay, next. That was step 1, solve for y. Step 2 is to pretend it says equals and graph your line. And we have to remember that if you have one of these 2 inequality symbols, you're going to use a dashed line. And if you have one of these 2 inequality symbols, then you're going to use a solid line. Well, we have a less than sign, so we're going to pretend it says equals and graph a dashed line. Okay, let's do that. So, you'll notice that when I solved for y, I put it in the slope-intercept form because I knew that this was coming. So let's start by plotting the y-intercept of 3, and then using the slope of 3/5 to rise and run to get more points on our line. Okay, so I'm going to need to run 5 to the right, which means I need just a little more of my graph over here. So 4 and 5. Okay, here we go. So from the intercept, we're going to rise 3, 1, 2, 3, and run 5. 1, 2, 3, 4, 5. All right, and we've reached the edge of the grid. Now we're going to go back the other way and do the opposite. So instead of up 3, right 5, we'll go down 3, left 5. 1, 2, 3, 1, 2, 3, 4, 5. Now this is a linear inequality, and for that reason, we're going to connect these 3 dots with a line, a dashed line. If you are using pen right now, I'm going to recommend that you put the pen away and get out a pencil, because once you draw a solid line with a pen and then realize later it was supposed to be dashed, there's nothing you can do to fix that. So you want to be using a pencil for this particular skill. Okay, there we go. We've now created a dashed line, and that was step 2. Okay, step 3 is the shading step. And the shading step is actually very easy. You just have to look at which variable you solved for and the inequality symbol that you see. In our problem, the variable is y, so that means our only shading options are up or down. And the inequality symbol is less than, which means we're going to shade down. So I know that I'm going to shade below my green dashed line. So what I'm going to do is I'm going to create a boundary to block in my shaded region, and I'm going to shade below my green dashed line. Notice how I'm filling in the entire area. This is what you want to do whenever you're creating a graph. And the reason why is because any ordered pair inside this shaded area would satisfy this linear inequality. This is very easy and very quick to prove. Pick any point you want inside the shaded region and then replace x with the x coordinate and y with the y coordinate, and you should get a true statement. For example, we know that the point 0, 0 is inside our solution region. So if we were to replace both the x and the y in this inequality statement with 0, we should get a truth. Well, 3 times 0 is 0, 5 times 0 is 0, and you subtract them, 0 minus 0 is 0. So we would get 0 is greater than negative 15. That is a true statement. Therefore, that validates and gives us confidence that we probably solved this problem correctly. We have now graphed the inequality.